All right, welcome. It's Friday. We made it through another week. Congratulations. This week was a little bit easier than the previous ones. But, anyways, what we are dealing with right now is we are walking through the continuous probability distribution that is called the standard normal distribution. The standard normal is a very specific version of the bell-shaped curve that is called the normal curve. The normal curve has kind of the shape of this ugly thing behind me here. Okay, and essentially the normal curves will change. There's a whole family of normal curves. They all have a bell-ish shaped curve, okay? But they vary about where they are centered, left and right, and they are varied a little bit upon how narrow they are or how pulled apart they are, okay? So where it is centered horizontally is essentially a change in the mean, okay, and which is a central tendency. So if the mean is 5, if it's centered around 5, this whole bell-shaped curve is centered around the number 5. You got half above 5, half below 5. If it is centered at minus 3.2, it's centered where, you know, the peak is a negative 3.2. Half of the curve is above it, half of the curve is beneath it, right? So depending on where we are in terms of where the mean is, this curve has shifted either to the left or to the right, okay? The second thing is how wide it is, okay? How much variation there is inside of there. It could be a curve that is a bell-shaped curve that is very narrow, and I will draw one that is very narrow. Okay. This would be an illustration of a normal curve, okay, that would be relatively narrow. Now, this is a probability distribution, so the area under this curve, this whole area here, if we count all of that, that area has to equal 1.04%. Right? So any probability distribution has underneath it an area of 1. Right? I said this is one curve, but there is also a normal curve that is a different color out. That is much more spread out. Okay. I centered these both so that they'd be at the same spot, so they both have the same mu, the same middle, right? But the second one that I drew is a bell-shaped curve, but it's a lot flatter. Okay? By being a lot flatter, there is more of a probability of getting a number far away. Okay. Now, what was our measure of dispersion? Well, our measure of dispersion was either sigma or sigma squared, right? Sigma is the standard deviation. Sigma squared is the variance. Remember, The sigma and the sigma squared are tied together. One is the square of the other. The standard deviation is the square root of the variance, but they're all, identical, right? So we have two charts that are drawn, right? This one has a higher sigma, because of that, a higher sigma squared than this one does over here, right? They're both centered at around the same spot. Well, it turns out that you see this one here, not only is it more centered, but it's also taller. Why does it have to be taller? Because the area under this purple line has to equal 1. But what else is true? The area under this blue line if it is a normal distribution, it is a probability distribution. What is this area? This is the same, right? So when we start talking about this, one of the things you've got to recognize is that when it's just like a balloon, when you push the sides of the balloon together, what happens? It bulges out on the top, right? What happens when you take a balloon and you pull it this way? It becomes flatter, right? So the flatter it is, the lower the top of the hill is going to be. You push these things together, and it's going to be popping up that way, right? But still, you will have this bellish type shape. Okay? And you have that in both particular cases. So, what we are going to focus in on entirely today is the case, one particular normal distribution, and it is called the standard normal. It is the one that is in the back of every textbook, and we will spend today teaching you how to use the standard normal tables that are in the back of the book. Okay. What is a standard normal? It is a normal distribution that has characteristics. It is centered at 0 and has a sigma of 1. Okay? I mentioned some other textbooks point out that sigma squared is 1. In a standard normal, whether you define it as being sigma equals 1 or sigma squared equals 1, doesn't matter because 1 squared is 1, right? Okay. But it is the standard normal, centered at 0 with a sigma of 1. So if it's centered at 0, these are positive numbers. And then there are negative numbers on this thing. All normal tables or all normal distributions are symmetric around this line. This line is the mean, turns out to be the median, and it is the highest point, and we will call that a mode. They're all centered at the middle. Okay? A normal curve is symmetric around the middle. And if we are looking at the standard normal, the middle is 0. And you've got numbers above, numbers below. Okay? the area under the whole curve from minus infinity to positive infinity has to equal 1, right? So, when we ask a question about what is the probability of something that happens that somebody tells us is distributed according to the standard normal distribution, okay, we will be looking at the area above, but below the line, above the horizon, but below the line of the area of question. So if I ask the question, what is the probability of being between 1 and 2? Could be a straight line up. The probability of getting a result inside of that interval is the area under the curve of that interval. Okay. What is the probability of getting an answer from minus infinity to positive infinity? Well, it is the area of the whole thing, right? And what's the area of the whole thing? 100%. Okay. Probability that you get some number above or beneath from minus infinity to positive infinity, your number is going to fall into that category. Every number will, right? Regardless how small it is. Probability of getting a number from minus infinity to positive infinity is 1, right? Probability of getting the number from 1 to 2 is not the whole area, but the area that is shaded. Okay. Here's a question. What is the probability of you getting a number over 0? Probability of getting a number over 0 is what? It's that shaded area. Okay. Now, I know we haven't yet gone to the tables in the back of the book, and I imagine that none of you know the mathematical formula for calculating this. It's a mess. Right? But many of you, most of you, should be able to answer this question. What is the probability of being between 0 and positive infinity, to being on this side, getting a number on that side? I gave you a clue. Okay, I got somebody. Somebody said 50%. Right? Why is it 50%? Because it is half of the area. This area is identical to that area. This area plus that area equals 1. So this area has to equal 0.5 or 50%. Okay. Good. You know 1. By the way, that's going to come in very useful. A little less useful in this class, in this people who use our book than somebody else's book, and I'll explain that in a little bit. Okay. But we know this to be true because we know that the normal curves are symmetric. One side is a mirror image of the other, and therefore the same size. Okay, well, let's go back to our original problem. And our original question was, what is the area between 1 and 2? All right. And that would be this area And that will represent the probability of having gotten a result that was between 1 and 2. Okay? And in order to get this, okay, we will need to go to a normal table in the back of the book. Okay? We can't just draw this and look at it and say, well, you know, I can figure out how much that is. Okay. If you were a math major, maybe you could. All right. But it would take you quite a while, and it wouldn't be worth it. Why wouldn't it be worth it? Because that's why we have help in the back of the book. For those of you who are able to, go back into the very appendix in the back. And it is on page 568 and 569, and you will see tables. Okay. The title of the table is Cumulative Normal Probabilities. Okay. Cumulative normal probabilities. Okay. They didn't add in the word here standard normal. But anytime you get it in the back of the book, they're talking specifically about the standard normal distribution. Okay. It turns out your book has 2 pages in it. Okay. The first page has negative numbers, and the second page has positive numbers. And I'm going to show you these in 1 second, because I believe I have them. I thought I had them. I'm trying to find them here. I have them here. So what I am going to do is I am going to make my screen so that you can see my screenshot. Okay, just have to get there from here. Okay, where's my screenshot? Hopefully I didn't erase you guys. There we are. Okay, share applications, share entire screen, share. I said share. Sunny, but share. Okay, there we go. You guys should be seeing my screen, which is a infinite mirror type thing, right? Okay. And so now I'm going to go to the first of these 2. And the one that I'm looking at right now, can somebody just verbally say, yes, I see a normal table?
Yes, sir.
Okay, super. Okay, so this is the normal table that's one of the 2 that is in the back of your book. This is the second of the 2, actually. It is the one on page 569. Okay, and I'm going to walk you through here how to read this table. Okay, but before I walk you through it, let me point out that every stats textbook has a normal table in the back of it. Furthermore, you can get the normal table on the internet all over the place, right? All you have to do is Google standard normal table, and you're going to get thousands of sites that you can get the standard normal table at. One thing that I absolutely recommend that you do, regardless of how frequently you use normal tables, is look to see whether there is a diagram on the top of the page that shows you what it is that the tables show. Okay. They don't all show exactly the same shaded area. And if they don't show the shaded area, okay, if they do show the shaded area, you are going to feel a lot more comfortable using that table. Okay. So, in this particular case, your book does have the shaded area. In your book, it is a light blue shade, which when I put it on the Xerox machine doesn't show up. So, you know, I shaded it with my wonderful artistic skills that you guys have become accustomed to, right? But this is shaded in the back of the book. And what it will tell you is it will tell you the area, which is the same thing as the probability, of the interval that is shaded. So in this particular case, it is shading from minus infinity to this number z, this letter z, right? And that is what this table shows. The z can be found as a combination of going down the first column. By the way, when you guys are seeing my screenshot, can you see my arrow that's pointing to here or not?
Yeah.
You can see my arrow. Good. Thank you. So the z is along this axis and this axis. It starts by going down, which gets you to the first decimal place, or the first decimal place after the period. So 0.5 brings you here. And then the next decimal place is along here. So 0.51, go to 0.51 is in that column. And so right here is your result. The shaded area is from minus infinity to 0.51 is 0.6950. Okay? Or what is that in terms of percent? 69.5. That shaded area shows that you are 69.5% likely to get a number from minus infinity to a positive 0.51. Right? From minus infinity to 0.10 would be a different number. Zero, if we were looking right here at z being 0.10, this shaded area would be smaller, right? It would be all the way down to here. But what would that shaded area be? Going down to 0.10, and these are positive numbers, okay? 0.10 would be 0.5398, or 53.98% of the time. Okay. Now, you guys had something just a few seconds ago, a standard normal, and I asked you what is the probability what? Of getting a number that was above 0. Well, you guys came up with that answer and said it was 0.5. Here is the question. What is the probability of getting a number less than 0? Which would mean from minus infinity to 0.000. Well, this is centered around 0, right? So what should that be? And I know somebody just typed something, but I can't see it because my full screen is on this. It should be 50%, right? Well, let's see what the table says. What is the area from minus infinity to 0.00? Go down to 0.0. 0.00 is this column, right? 0.0 is this row. 0.0 as being the next decimal place is that one. And what does the table tell us? 0.5 or 50%. Right? Bingo! The table tells us something correctly that we should know. It makes us feel warm and fuzzy that we understand how to read the table. Okay? Now, let's go back, and I'm going to turn this off and I'll come back to it in a few seconds. Go back to our original problem that's on the board. Stop sharing so you guys should see me again. All right, I have to get to where I can see myself again. Okay, I can see myself again. All right, so we were looking for this shaded area. Notice the table did not give us a shaded area like that. What did it give us? It gave us an area that looked like that, right? That purple area, everything underneath here, is what the table would have given us. It would have given us from minus infinity to 2. Right? Well, the table also would have given us a different spot. Let's take green. Hopefully these markers work. From the table, I could have gotten this area, this green area. The purple area was what? Minus infinity all the way to 2. The green marker was from minus infinity to 1. What did we want to see? We wanted to see the red one, right? Well, what is the red area? It is the purple area subtracting the green area. So what's the purple? It's the purple area minus the green area. And that is when I subtract the green and I erase the green from the purple, what's left? Just the red, right? I lost my red marker. I don't see a red marker. Oh, no more red today. Okay. This equals red. That's the new red. Okay, magenta. All right. So let's look this up in the table. This is the area to positive 2. This was the area that went to positive 1. And what's after I do the subtraction, that's what I will end up with. All right. So now let me go back to sharing my screen and share application, share entire screen. Okay, and I believe that was the one there. So the first thing that we're going to look for is the purple number, the area all the way from minus infinity to the positive 2. Okay. So when we go down, down, down until we get to the 2's, and 2 point, I wish it's had 0, right? The first one says 2 point and then it's blank. The one underneath it is 2.1, 2.2, 2.3. I want the row that's 2.0. And what do I want the second decimal place to be? A 0 as well, which is this first column, right? So I go down to 2.00 and I end up from 0.9772. 0.9772. 0.9772, right? Then what I wanted to do was find the green area, because that's the area I want to subtract. What is the green area from minus infinity to 1.00? 1.00 is this number right here, which is 0.8413. 0.8413. Did everybody see where I got that? Right there?
Yes, sir.
Okay. So what did I say it was? 0.8413. Okay, stop sharing. You guys should see me again. Okay. Oops, that's the wrong button. Okay. Camera. Okay, that way I can see me. Okay. All right, so what did we get? The purple area was 0.9772. The green area was 0.8413. I want to erase the green area from the purple area so that all that is left is the red area, right? So my net result is 965. And if I did my math right, this red area, therefore, is 0.1359. Does that make sense? So doing these, the book isn't going to ever tell you from 1 to 2. You're going to have to take what the book gives you and create from what it gives you the area that you're interested in this particular way, to get to this red area, I had to get the area from minus infinity all the way to here, and I had to then subtract off that part that I didn't want, which was from minus infinity to here. I cut that off, and bingo, I end up with 0.1359 or 13.59%. 13% of the time, I will get a number between 1 and 2 if it is coming from the standard normal distribution. Okay? Now, I could have done this with any interval, with any numbers. Okay? Now, a couple things to point out is theoretically these normal curves go to infinity. Okay. Realistically, they get down infinitesimally small where you can't even recognize it without, a microscope and so on and so forth. let's go back and look at the table, and I'll show you that this happens. It was not a complete accident that I went 0, 1, 2, 3 instead of 0, 5, 10, 15, 20 or so, right? Because quite quickly, the standard normal will approach areas that are really, really, really close to 0. Theoretically, they're not 0, right? But it would take an electron microscope pretty quickly to see it. So let's go back to the standard normal. Okay? The standard normal. You need to go back to share application, share entire screen. That's the screen I want to share. Okay. And let's go back to this. So notice these are the numbers that it'll go to. Let's go toward the end. The last number that it really looks at your table is 3.09. Okay. Now, some other textbooks will go a little bit further, but what is the area from minus infinity to 3.09? It is 0.9990. 99.9% of the area is covered from minus infinity to positive infinity. So how much is beyond that? Well, 0.001. 0.001 would be 1/10 of a percent, right? And if we had, went down to like a 3.5 or 3.6 or down to a 4, this would have been a 0.9999 something or other, which means essentially although theoretically there is something left to the right-hand side in the tail, it's almost unmeasurably small, right? So when we look at when we look at standard normal tables, standard normal distributions, okay, getting a number that is larger than 3 or smaller than -3 almost never happens. It is a very, 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 very strange result. Okay, so when we look at the graph that I had of the standard normal, okay, you will see that it, was very much ended at 3 and ended at -3. 4 and -4. Boy, it'd be so infinitesimally close to 0 that all of the area from that point on forward, would be 0.000001 or something really, really, really small, right? Okay, so anyways, those are kind of little results that we have. Did you guys understand how we did this? All right. Now, let me take you to the other table. Because remember the table that I had up there just started at 0. It had the positive numbers. It had from minus infinity to the positive numbers, right? The second one, share application screen. I got to go back to my window. Okay, and I have this one, and this one is the page earlier, has the shaded area again, from minus infinity to z, but the z's here on this page are the negative numbers from minus infinity to this number, right? And z, whatever number it is that you're looking for, you look down this column and over this column for the digit after that. So if you're looking for a minus 1.96, minus 1.96, you'll see I had already circled 0.0250. So what does that say? From minus infinity to a minus 1.96, okay, with z equals a minus 1.96. Remember, on this one, all of these z's are less than 0, so they're all negative numbers, right? Minus 1.96 had 0.025, or 2.5% of the time you would get a number less than 1.96, negative 1.96. Right? So when you look at this table, it essentially is the identical table, okay, that we have in the first case. Right? Again, looking at the graph, it shows you what you are seeing from minus infinity to all these different numbers, right? And from minus 0.00, we get that area again as 0.5. Okay. Be a little bit careful. 0.01, if it's a positive, is not this number. It's the one on the positive side. Everything here is a negative number, right? Okay. So it's a negative 0.03 if it's in this column here. Negative 0.00, you know, obviously is neither negative or positive, but this is the negative table. Now, some books will not give you this page. Why? Because this book, printing this in this book requires a page, a side of a page. Pages cost money. Textbook manufacturers are greedy. Oftentimes they will not give you this page that they think you don't need to have. Okay. Why do they think you don't need to have that? Because the textbook publisher says, well, I gave them the positive one, the other page. I gave them that page. Why can't they figure it out from this page? And the answer is you can, right? But you got to understand a little bit of the trickery of the symmetry of the normal distribution. If we were looking from minus infinity to a minus 1.96, that shaded area would be the same as from 1.96 positive. So remember, if there is a mirror right at this, and we wanted to find an area from minus infinity to some number, that would be the same thing as that number to positive infinity on the other side of the mirror. So if we wanted to find the area from minus infinity to a minus 1.96, that would be the same thing as finding the area from a positive 1.96 to positive infinity. It would be looking for this non-shaded area right here. Well, how could we have possibly done that? Well, we can go on this one to what? 1.96, 1.9, go find the 6, column is here, 1.96, and the arrow is pointing to 0.9750. Right. What's the shaded area? From minus infinity to a positive 1.96. This area is 0.9750. If this shaded area is 0.9750, what's the unshaded area? It's got to be what? 1 minus that, right? 1 minus 0.9750 is 0.0250, which is exactly what we saw on the other table. So some textbooks are not nice to you. They won't give you that negative number because they figured, you know what? These are college kids. They can figure this out. And that way we can save a half of a page of paper, which, since many of you now are getting textbooks that aren't even paper, there's really no excuse for it, right? But many textbooks will only give you either this table or the one on the previous page. Some will give you a table that doesn't look like either of them. It is a table from 0 to this. Okay, and I think I'm out of time, so I'm not going to go find it. But if you guys went out onto the internet, looked for standard normal tables, you will get some standard normal tables that have a graph that is different than the one that is on here. Why? Because the table is giving you different information. Regardless of which standard normal you're looking at, you can get the right answer. You just have to go through different steps in order to get it. All right. Anyways, I put some homework out there for you to practice, not just standard normal, looking up standard normal things in your book, but there's also a question or two, there may only be one question, on uniform distributions, continuous uniform distributions. So there's a homework out there that is due a week from today. All right, any questions? Oh, by the way, your tests have been graded, and you should be able to see them out on your scores out on Blackboard. If you need to look at your, what you handed in to me, email me, but you should be able to figure it out, I think, from your notes. Okay? And I will post this weekend my version of the test, the answer key, so you can use that to compare as to what the right answer would have been, at least in my opinion. All right. Okay, with that, I am going to, call it a day. No comments, questions, anything? Thank God that the weather was decent this week and we all had electricity. All right. Take care, guys. Have a wonderful weekend, and we'll see you everybody back here on Monday. Bye-bye.